Okay, in today's session, we will focus on the concept of discrete memoryless channel and how we can correlate this discrete memoryless channel concept to the concept that we have already learned in the fundamentals of information theory. In fundamentals of information theory, we have defined the two particular definitions. First, the definition related to amount of information, that is how much information that a message content. We have defined it by say ik is log of 1 upon pk to the base 2. This is the first term that we have defined. Another term that we have defined in the information theory is the entropy, capital H, where entropy is nothing but the average amount of information that is being generated by the information source. And another term that we have defined, the third term, that is R, that is information rate, where information rate is focusing on how many bits per second the information that you have transmitted from the transmitter end. So whenever we discuss the term I, H and R, our main focus was on the block of information source, right? And if I just look at the concept of information source or the block schematic of the information source, whenever we came across this block schematic, we have first block as the information source and how much amount of information is generated by that particular source that is been considered or measured by using the terminologies ik, h and r. Now we have to focus on another term that is called as channel. So if I just look at the concept of channel, I came across that I have a transmitter part, I have a receiver part. So I can consider this is nothing but my transmitter, this is nothing but my receiver, and in between transmitter and receiver I have a part that is called as channel. Now I have to look into the concepts of information theory with respect to channel point of view. How X as a transmitter will transmit the data, Y as a receiver will receive the data, and in between transmitter and receiver, how channel works and how we can calculate the information shared or transferred by a channel from that source to information. So that particular information theory measurement we would like to carried out in this particular lecture.
ये मतलब कि
मेल लिंक reset password.
So what we are talking about is the case related to the channel. We have information source concepts that we have already learned in the basic information theory part. It's the same concepts. Now we want to apply it for the channel. So once again, I'll repeat that discussion where my focus is on transmitter end. So this is my transmitter from which I'm transmitting certain symbols x0, x1 till xj minus 1. Capital X is the random variable which generates these particular source symbols from the transmitter end. Similarly, at the receiver end, I have a receiver, and this receiver is represented by a random variable capital Y, and the received symbols are y0, y1 till yk minus 1. And what is in between transmitter and receiver is nothing but the channel which is going to transmit a data from transmitter to receiver. Now we are talking about this particular channel and we are interested in finding out how much amount of information is exchanged from transmitter to receiver or from receiver back to transmitter through this particular channel. That the concept we would like to understand, and for that purpose we have defined the terminology called as discrete memoryless channel. Here we want to understand all these information theory concepts only for a typical type of channel, and that channel is discrete memoryless channel. Earlier also I have explained you the concept of discrete memoryless channel. Once again I'll repeat here. What is this? Is a channel which transmit discrete information. Transmit discrete information means your information x0, x1, xj minus 1 is in discrete nature, which is been transmitted by the channel, and at the receiver I'm going to receive the discrete information. So discrete information example is binary data, unary data. All these are what? Discrete information is transferred by the channel. Therefore, it is called as discrete channel. Again, it's a memoryless channel. Memoryless means my channel does not contain, does not have any memory, and it does not store any data that you are going to transmit. For example, your fiber optic cable, your coaxial cable, these are all memoryless channel because they do not store any sort of data. That's why the channel is called as discrete memoryless channel. So what is discrete memoryless channel? Is a statistical model with an input X and output Y, where Y is a noisy version of X. No doubt X has been transmitted along the channel, noise get added, and I'm going to receive the noisy version of the Y over here. So this is what a discrete memoryless channel. Now, we need to define certain probability concepts for this discrete memoryless channel. To understand these particular concepts, let us look at here how this concept I can understand from the probability perspective. So to understand this concept, I will first define that I have a transmitter. This transmitter is going to transmit certain number of bits, okay, and this starts from, let us say, x1 is the first symbol, x2 is the second symbol, similarly x3 is going to be the third symbol, and like that way I could have another symbol here which is represented by, say, xk or xn, these many number of symbols, and this particular portion is the portion related to the transmitter. In between the transmitter there is a channel. Transmitter and receiver, there is a channel. Similarly, at receiver end also I'm having the symbol that is y1, the symbol that is generated here which is y2, and similar to that I have last symbol generated, that is yn. So here xm I can consider, here you can consider yn. Now what happens between the channel? Suppose I am going to transmit x1 from the transmitter, at the receiver I may get y1, or if I transmit x1 I may get y2, if I transmit x1 I may get yn. This is going to happen between channel. Some noise is corrupted, is going to corrupt your signal, and if you transmit x1, possibility that you will get y1, possibility that you will get y2, possibility that you will get yn, and the same thing is applicable for all rest of the symbols x2, x3, xn. So there are n number of possibilities, m number of possibilities with which you can transmit the data, and n number of possibilities with which you receive the data. Now I have to define this probability statically. So I will define capital X is nothing but the random variable which represents x1, x2, x3, xm. Capital Y is going to be the random variable which will represent y1, y2, yn. Now if I want to select this messages x1 to xm randomly, right, from the random variable x, then I can define the first probability, that is p of x. P of x is nothing but the probability with which the symbol x1 to xm is selected for transmission, that is the probability x. Once you transmit this data from transmitter to receiver, at the receiver end, I may receive the symbol y1, y2 or yn, which will define another probability that the received symbol is y, that is p of y. So p of x is defined at the transmitter end, p of y is defined at the receiver end. Now I have to define few more probabilities here in order to understand the concept of entropy for this particular channel. So what are the probabilities? Now I want to define one more probability, that p of y, p of y given x. P of y given x is nothing but p of y dependent upon x. This is dependent probability. And whenever you take P of y dependent upon x, x is known to you. As x is known to you, this probability is known or is can be calculated at the transmitter end, because at the transmitter end I know the value of x. So what is P of y given x? P of y given x is what? You know the value of x, that is you know that the x1 is transmitted. What is the probability that y is received at the receiver? So I am predicting from the transmitter end towards the receiver end that what is the probability of that y will received if I have transmitted x. Similar way, I can define one more probability here at the receiver end. At the receiver end, y is known to me. So I will define the probability x dependent upon y, because y is already known to me. So what is this P of x given y? P of x given y is received. Y1 is received. What is the probability that x1 is transmitted, x2 is transmitted, or xm is transmitted? So this is what the dependence probability y given x and x given y. Y given x is calculated at the transmitter end and x given y is calculated at the receiver end. Why at the receiver end? Because y is known to me. Why at the transmitter end? Because x is known to me. So P of x and P of y given x, we can calculate at the transmitter end. P of y and P of x given y, we can calculate at the receiver end. Now, what is remaining in between? This is nothing but your channel. So for this channel, what is the probability that we can calculate? Now, if I'm in between transmitter and receiver, that is along the channel, I can look at towards transmitter. I can also look at towards receiver. So in between transmitter and channel, I can calculate the probability that the probability which is common to both x as well as y. So I can define here the probability which is common between x and y. Common between x and y is nothing but P of x comma jointly occurred with y. So P of x comma y, that I can see along with the channel. So these are what the probability knowledge with respect to channel that we required in order to understand the information transmission carried out along the channel. So what are the probabilities? I will repeat. P of x is the probability that symbol x1 is selected for the transmission. P of y is the probability that the symbol y1 is received at the receiver end. P of y given x is the probability that x is known to me. What is the probability that y will receive if I have transmitted x1? Similarly, P of x given y will be the what is y is known to me. So what is the probability that x1 is transmitted if y1 is received, or x2 is transmitted if y1 is received? So these are what? Conditional probabilities. And the probability which is jointly associated with respect to transmitter and receiver is nothing but the probability P of x comma y, which you can measure along with the channel. If these five probabilities are known to me, I can easily calculate the information exchange carried out between transmitter to receiver by using the terminologies of entropy, what we have defined in the information theory part. Okay. So after understanding all the concepts related to the probabilities of the channel, now we'll try to understand the concept of channel matrix. Now to understand the concept of the channel matrix, we have to define a matrix. What this matrix? This matrix consists of rows and columns, right? Rows and columns, you have to take y and x as the parameter, like x parameter on the columns, y parameter on the rows. Then you have options like x0. Okay, I may define this particular terminologies, like on the column I have x0, right? Then x sorry, on the row I have x0 x1, and on the column I have y0 y1 yk minus 1. So if I look at this particular matrix, p of y0 given x0, y1 given x0, yk minus 1 given x0, that means at the first row I have x0 with me, and at the column I have the y0 y1 yk minus 1. Similarly, if I look at the second row, I have x1 component, and for this x1 component I can define the terminologies like y0 given x1, y1 given x1, yk minus 1 given x1. So that way I can form a matrix, and that matrix is called as the channel matrix. In the examples of discrete memoryless channel, we could able to design such a channel matrix. The channel matrix that we have defined here is basically denoted as P of y given x. P of y given x, because y0 given x0, y1 given x0, like that. Similar way, we can also define another matrix, and that matrix is nothing but P of x comma y matrix. So P of x comma y matrix, it consists of the rows and columns as P of x1 comma y1, x1 comma y2, x1 comma ym, similarly x2 comma y2, y1, x2 comma y2, x2 comma y. So here also on row side there is x1, x2 till xn, and on column side there is y1, y2 till ym. So this particular matrix is called as joint probability matrix. So you have conditional probability matrix, you have joint probability matrix, and your channel is defined by this type of channel matrix, either a joint probability matrix or a conditional probability matrix. So these are the two types of ways by which you can define the term channel matrix. Okay. Now, we will have this particular probability combinations which I have already explained to you. Joint probability P of x comma y. P of x is called as marginal probability matrix of x. P of y is called as marginal probability matrix of y. P of x given y is conditional probability matrix of x given y. P of y given x is a conditional probability matrix of y given x. Now, we will look into how we can define these particular matrices as far as the channel is concerned. Let us take a typical example of binary symmetric channel. Okay, just try to understand this particular basic simple channel, because while solving the examples you have to look into similar implementations of higher array channels, M array channels, where M could be 2, 4, 8, 16, like that. So this is a binary symmetric channel. As this channel is binary symmetric, we have a source which contains two symbols, binary 0, binary 1, denoted as x0, x1. Similarly, receiver also contains two symbols, binary 0, binary 1, that is y0, y1. Now, the channel is established in such a way that 0 is transmitted, 0 is received. 0 is transmitted, 1 is received. 1 is transmitted, 0 is received. 1 is transmitted, 1 is received. And I have also defined the probability with which 0 transmitted and 1 received is a false alarm. 0 transmitted, 1 received is a false detection. 0 transmitted, 0 received is a correct decision. 1 transmitted, 1 received is a correct reception. 1 transmitted, 0 received is the false reception or false detection. Right? We have defined that the probability of 0 transmitted, 1 received is P. We know that the total probability is what? 1. Therefore, the probability of 0 transmitted, 0 received will be 1 minus p. Similarly, probability of 1 transmitted, 0 received, if it is p, probability of 1 transmitted, 1 received will be 1 minus p. And as here pp and 1 minus p, they are similar probabilities. This type of channel is called as binary symmetric channel. So this particular channel is called as binary symmetric channel. So I can define this particular channel as binary symmetric channel. So for this binary symmetric channel, we can define probability of error. This is the probability of error, that is P. Why it is error? Because 0 is transmitted, 1 is received. 1 is transmitted, 0 is received. So this is probability of error will be summation k is equal to 0 to k minus 1. P of y is equal to yk. Y is equal to yk. Yk nothing but P of y0, P of y1. And which is summation k is equal to 0 to k minus 1, 0 to j minus 1 p of yk given xj multiplied by p of xj. Because we want to find out this value of p, we know what is the probability of xj, we know what is the probability that xj is transmitted and yk is received. So in this case, if I assume that both probability of x0 and x1 is equal, that is half, we can calculate the probability of error, and that probability of error is coming down to p, which is our assumption for binary symmetric channel. So this is your binary symmetric channel. Now we want to understand the concept of entropy, okay, for this particular channel. So how we can calculate the entropy? So in my earlier diagram, I have defined, right, what I have defined, p of x. I know the formula of entropy. Entropy is what? Summation pk log of h of x. See, h of x is my entropy. What is entropy? Summation pk log of 1 upon pk to the base 2. That is the formula for my average amount of information. Now, if I have p of x, I can define h of x. If I am having p of y, I can define h of y. If I know p of x given y, I can define h of x given y. If I know p of y given x, I can find out h of y given x. And if I know p of x comma y, I can find out mutual information between the two channel I of x given y. So from the understanding of the probabilistic knowledge, what we have discussed here, we want to define different types of entropies. Entropy for transmitter h of x, entropy for the receiver h of y, entropy for x given y, entropy for y given x, and mutual information I of x comma y. All these particular 5 definitions we want to make from the knowledge of the probability that we have understood for any particular type of channel. So let us define h of x. H of x is very simple. X is known to me. So simply pk log of 1 upon pk, where pk is the probability of x. Similarly, h of y, it could be probability of y. I could have same formula, p of y log of 1 upon p of yj or yk, like that. Now, I can define another entropy, h of x given yk. H of x given yk, I can find by using the formula p of xj given yk. See, xj given yk log of 1 upon p of xj given yk. But if I do the averaging of this conditional probability, I can find out the formula for h of x given yk into p of yk will be h of x given y, which is summation k is equal to 1 to k, j is equal to 1 to j, p of yk, p of xj given yk into log of 1 upon p of xj given yk. But if I look at this particular thing, p of yk into p of xj given yk is nothing but my joint probability p of xj comma yk. Therefore, the h of x given y, the formula that I am generating for h of x given y will be summation k is equal to 1 to k, j is equal to 1 to j, p of xj comma yk log of 1 upon p of xj given yk to the base 2. Please note down this formula for h of x given y. The formula for h of x given y will be summation k is equal to 1 to k, j is equal to 1 to j, p of xj comma yk log of 1 upon p of xj given yk. Now, if I want to modify this formula for h of y given x, h of y given x, okay, let me take this particular formula, h of y given x. This is h of x given y. Now h of y given x, everything will be same, only instead of xj given yk, it will be yk given xj. So I can have the formula h of y given x, summation j is equal to 1 to j, k is equal to 1 to k, p of xj comma yk log of 1 upon p of yk given xj. So it's very simple to remember both this formula. If it is x given y, here in the log term it is xj given yk. This term is joint probability. Similarly, y given x, here yk given xj, this joint probability is common. And if you are finding out h of x comma y, then in the both the case it is joint probability p of xj comma yk log of 1 upon p of xj comma yk. And we can establish the relationship between all these three formulas, and the relationship is what? H of x comma y is equal to h of x given y plus h of y, and h of x comma y will be h of y given x plus h of x. Given y is known to me, therefore addition is h of y. X is known to me, therefore addition is h of x. So all these formulas we required while solving the examples. Once again I will note it down. Please note down all these formulas. H of x given y, summation k is equal to 1 to k, j is equal to 1 to j, joint probability log of 1 upon conditional probability xj given yk. Same formula I can modify for y given x, joint probability log of 1 upon conditional probability yk given xj. And h of x comma y, joint entropy will be joint probability log of 1 upon joint probability. Three formulas, and the fourth and fifth formula are h of x comma y will be h of x given y plus h of y. What is given, that will get added. H of y given x, what is given x, that will be added h of x. All these six formulas we required in order to understand the implementation of entropy calculation for various types of channels. I hope I try to explain you the different entropies which we can define, and this is how they are related. H of x at the transmitter end, h of y at the receiver end, h of x given y at the transmitter end, y given x at the receiver end, and mutually between transmitter and receiver I of x given y. All these calculations we would like to understand for various types of channels. So let us understand the physical significance of all the entropies that we have defined with respect to communication network. So first entropy, I'll take h of x. H of x is average information per character of the source. Source means transmitter. So the entropy of the source, entropy of the transmitter is nothing but my h of x. What is h of y? Average information per character at the destination. Destination is your receiver. So entropy at the receiver. What is h of x comma y? Average information per pairs of transmitted and received characters. So it's an entropy of the system as a whole. System as a whole entropy is nothing but h of x given x comma y. What is h of y given x? Specific character xk being transmitted and one of the permissible yj may be received. So it's a measure of information about the receiver where it is known what was transmitted. Look at a small difference that you observed in this particular diagram and the diagram that I explained. P of y given x is present at the transmitter, but h of x given y is present at the transmitter. This is exactly opposite. H of y given x is known at the receiver, but earlier we mentioned P of x given y was known at the receiver. So this is what somehow exactly opposite to that of probability. Okay, that's why whenever we define H of y given x, I know that what is transmitted, right? And I'm trying to find out the measure of information about the receiver, that is y. I know what is received. I am trying to find out the measure of information about the source, where it is known what was received. So these are what the physical significance of entropy is. Okay. So h of x and h of y give indications of the probabilistic nature of the transmitter and receiver. X comma y will give the probabilistic nature of the communication channel. Y given x indicates of the noise or errors in the channel. Similarly, x given y gives the measure of equivocation or how well one can recover the input content from the output. That we can understand from all these different types of entropies that we have defined for a communication network.